So this is an induction motor. This is the stator, okay, and this have the slots where you get the windings, okay, and then there we have this. That's a rotor. That's a rotating part of this motor, and here you can see there's a bearing there, right? And also there's a bearing here. If this bearing is damaged, let's say the oil is no more effective, okay? This cannot rotate like this. It will create a lot of losses. That's why we must also know windage losses, okay? This is very important. And we can see that this stator contains copper bars. These are copper bars like that all around, and they are shorted like that. So now, and so when there is power into the motor, this is the terminal block. Okay, the terminal block. All right. So now, when we supply this motor, the terminal block, which has to be on top here, that will run the wires that will come from these slots, go through this hole here, and out there. Okay, and then to this terminal block. So when we supply this motor, there's going to be some losses. The winding is here. There will be some losses here on this core. So remember the core loss, because this is an iron core that we use to make these slots. That's an iron core. Look at this. So there will be some losses, okay, of which we can have copper loss, which is due to the wires, the resistance of the wires that we are going to have here. Remember, I've removed the wires, okay? I'm just still rewinding that. So there will be losses there, and then there will also be losses, eddy current losses, the same in the core around here. Now, then, because this one will go through here, all right? Now, if I have the power into this motor, and I subtract all the losses here in the core, okay, and the winding, now the remaining power will be induced into this, okay, to the rotor. That's so that power that will cross through that stator, cross over the air gap, because this rotor enters into that that stator. There will be a gap, all right, an air gap. So the power crosses through the air gap into this. Now, because these are copper bars, there's going to be a copper loss also, which is I squared R loss. And so if I can remove the losses here, the remaining loss, the remaining power is what is going to be used in order to turn this. Okay? So it's going to be which, but now you can see that all these bearings, if they are not properly lubricated, all right, the torque that was supposed to rotate this, make this rotate, might be reduced, okay, due to some losses. That means there will be some windage and friction losses if this is not properly lubricated. Okay, there will be some windage and friction losses. Friction may be due to improper oiling. There's not enough oil or greasing of this bearing. Remember also that we are going to have a blade. The essence of the blade there is to make sure that you will cool off the heat that will be generated due to some of these losses. Okay, if not, the coil is going to get burnt. Okay, so that is it.